Okay, let's look at some more details regarding covalent compounds. When we're looking at bonds between atoms, you can actually have single, double, and triple bonds. Nothing more than that, but you can have those three. When you have a single bond, that means that only one pair of electrons is being shared. Okay, and when you have a double bond, you can assume it's two pairs of electrons are shared, and with a triple bond, it is three pairs of electrons. So let's take a look at, let's really take a look at what that means as far as looking at the Lewis dot structure of compounds. So let's say we have hydrogen gas. It's made up of two hydrogen atoms bonded to one another. Remember that each hydrogen has only one valence electron. So when you have two hydrogens bonded together, they share that pair of electrons. So maybe this one really belonged to this hydrogen, this one belonged to this one, but they are sharing. So actually they can each pretend that they both have two valence electrons, which makes them very, very happy. With double bonds, we can look at oxygen. So oxygen gas is made up of two oxygens, and if we look at the valence electrons of both oxygens, we can see why those two bond together. Now, remember that oxygen has 6 valence electrons. So, has 6 valence electrons. Now, the interesting thing here is that these two electrons will pair up and they will share, but then so will these. And the way you end up drawing that is with the two oxygens, like this. We show their pairs, and then they're sharing two pairs of electrons. So these electrons are being shared. And I didn't draw this to scale. This isn't actually what it ends up looking like, but it does have these 4 electrons that are being shared between these two oxygens. And sometimes you can just draw it like this. The same way with the hydrogen, you can draw it as one bond holding those two hydrogens together. With oxygen, it is 2 bonds. With a triple bond, let's look at nitrogen. Nitrogen gas also made up of 2 atoms, and if you recall, nitrogen has 5 valence electrons. So both nitrogens have 5 valence electrons. And remember, it doesn't actually matter where you begin when you're doing the Lewis dot structures. I did this so that I can show you that these electrons pair up, these electrons pair up, and these electrons pair up, showing you that there are 3 bonds. And here, if you were going to do the Lewis dot structure for the nitrogens, then you would show that there are 3 bonds holding those nitrogens together. And actually, I drew that wrong. Now, if I was going to show you the Lewis dot structure for the nitrogens, it would look like this. So those nitrogens, these 2 nitrogen atoms, are sharing 3 pairs of electrons. And again, if you were just going to do it with the lines, you would show 3 lines. Now, in addition to knowing that that you can have multiple bonds, there's another detail that you need to know. Some of these bonds have different names, which kind of sounds strange. So these are the types of bonds. Every time you have an atom that bond, or 2 atoms that bond, the very first one that is made is called a sigma bond. Or you might see it as Greek letter sigma bond. And that's true for every single covalent bond. The first bond that is made is a sigma bond. So with this double bond here, this one right here, the one that is the smallest, shortest, the one that is completely in between the 2 atoms, that is going to be your sigma bond. But then what is this one called? This additional bond. That one is actually called a pi bond, and this is pi, like the pi that you have seen in your math classes. Okay. So when you're looking at a triple bond, again, this one in the middle, the shortest, strongest one that is completely in between the two atoms, is your sigma bond. And then since it's a triple bond, the two additional ones are pi bonds. Okay? And there's really not much more that you need to remember about that, just that the first bond that is made is a sigma bond, and then any additional bonds that are made between those elements are pi bonds. Okay? Now, finally, the last thing I'll show you in this video, we have looked at several elements that exist in this form where there's two of them. Okay, so hydrogen is H2, oxygen is O2, nitrogen is N2. These are called diatomic. So I'm just going to make a little note here. Diatomic, meaning it has two. Oxygen, just a simple oxygen atom, does not exist alone. It's very unhappy that way. It's very quickly going to bond to something else, whether that's another oxygen or a hydrogen or anything. So there are 7 elements that are diatomic. Hydrogen being one of them, oxygen being one of them, nitrogen being one of them. But you also need to know that there are 4 more, and those 4 are some halogens that we've talked about: fluorine, chlorine, bromine, and iodine. Okay, so these are 7 diatomic elements that you need to know, you need to memorize. And if it helps you, I've also shown you that they make a 7 on the periodic table. If you start at nitrogen, I'm sorry, that's not true. If you start at oxygen and you go to nitrogen and then fluorine and then go down, you have 7, well, you have 6 there, and then just keep in mind that hydrogen is also diatomic. But if you can just remember that these 7 are diatomic, it's really going to help you out once I start giving you chemical equations that you have to write out based on just a sentence that I give you. If I just say something is reacting with oxygen, you have to remember that it's O2, not just O, because that doesn't exist. All right, I think that is enough for this video. See you next time.